Hello dear students, today I am going to explain the continuation of electromagnetic induction chapter. The topic is energy conservation during Lc oscillations. Energy conservation during Lc oscillation. Chapter name electromagnetic induction and AC. The topic name is energy conservation during Lc oscillation. Energy conservation during Lc oscillation. Right. Here, L refers to self-inductance of a given inductor or self-inductance of an inductor. Right. And C refers to capacitance of a capacitor. Right. L, self-inductance of an inductor. C, capacitor of a capacitance. Capacitor of a capacitor. Right. If an inductor of self-inductance L and a capacitor of capacitance C is connected to form a circuit is called Lc circuit. Lc circuit, right? If a capacitor of capacitance C and an inductor of self-inductance L is connected like this, then this circuit is called Lc circuit. Lc circuit. Lc circuit or oscillatory circuit or tank circuit. Right? Lc circuit is also called oscillatory circuit or tank circuit. Tank circuit. Right? Why it is called a tank circuit? Because the energy can be stored in this circuit. The energy can be stored in the circuit. Already we know that both the capacitor and the inductor is used to store energy. Used to store an energy. Right? The name of the energy stored in the capacitor is called electrical energy or electrostatic energy. Electrical energy or electrostatic energy, because the energy is stored in the form of electrical. The energy is stored in the form of electrical. So that is why the name of the energy stored in the capacitor is called electrostatic energy or otherwise called electrical energy. Electrical energy, right? And the energy stored in the inductor is called magnetic energy. Magnetic energy. Why? Because the energy is stored in the form of a magnetic field. Energy is stored in the form of magnetic field. So energy can be stored in both the capacitor and the inductor. The name of the energy stored in the capacitor, electrical energy or electrostatic energy, and the name of the energy stored in the inductor is called magnetic energy, because the energy is stored in the form of electrical in the case of capacitor. Here the energy is stored in the form of magnetic field. So that is why the name of the energy stored in the inductor is called magnetic energy. So in this system, the energy can be stored or energy can be maintained. So that is why this Lc circuit is also called tank circuit. And it is also called oscillatory circuit. Reason, whenever the energy is given to this circuit, an electromagnetic oscillation is set up in this circuit. Electromagnetic oscillation set up in this circuit. So that is why this circuit, Lc circuit, is also called oscillatory circuit, right? If capacitor of capacitance C and an inductor of inductance L is connected to form a circuit is called Lc circuit. Lc circuit is also called a tank circuit because energy can be stored in the circuit. And it is also called oscillatory circuit because when energy is given to the circuit, oscillation is set up in the circuit. So Lc circuit is also called oscillatory circuit or otherwise called tank circuit. The name of the energy stored in the capacitor, electrical energy or electrostatic energy. The name of the energy stored in the inductor is called magnetic energy. Magnetic energy, right? So whenever the energy is given to this system from some external source, okay, here an electromagnetic oscillation is set up in the circuit, or electromagnetic oscillation is produced in the circuit. Electromagnetic oscillation produced in the circuit. The electromagnetic oscillation that produced in the circuit have some definite frequency. Definite frequency. Such oscillation that exists in the LC circuit is called LC oscillation. LC oscillation, right? During this LC oscillation, the total energy of the system is always conserved. The total energy of the system is always conserved. So this is a topic today we are going to discuss, right? The name of the topic is energy conservation during LC oscillation. Let us consider an LC circuit. The LC circuit consists of a capacitor of capacitance C, which is connected to an inductor of self-inductance L. Right? This is a capacitor whose capacitance or capacity is C, and this is inductor. Inductor is also called a coil or a solenoid. Okay, the coil in the form of a solenoid is called an inductor. Right? Whose self-inductance is L. Self-inductance is L. Right? If the capacitor and the inductor are connected like this, then the circuit is called LC circuit. So this is LC circuit. Right? Here, a completely charged capacitor is connected to an inductor. Okay, so the capacitor, the total charge in the capacitor is maximum. That is, maximum amount of charge is stored in the capacitor. Suppose the maximum amount of charge in the capacitor is denoted by Q suffix M. Q suffix M, right? So when a completely charged capacitor having charge Qm is connected to an inductor, right? If there is no flow of current in the circuit, if there is no flow of current in the circuit, or there is no flow of current through an inductor, the inductor, only the energy is stored in the capacitor alone. The energy stored in the capacitor is taken as U suffix E. It is given by of Q M square divided by C. Right? So there is a capacitor. It consists of a maximum amount of charge, that is Qm. If there is no flow of current through the inductor, there is a maximum energy in the capacitor. The maximum energy in the capacitor is given by U suffix E is equal to of Qm square divided by C. Qm square divided by C. There is no flow of current through the inductor, so the energy in the inductor, suppose it is taken as U suffix B, which is equal to 0. Right? When a completely charged capacitor is connected to an inductor, if there is no flow of current in the circuit, the energy in the capacitor is a maximum, that is of Qm square divided by C. What is Qm? The maximum charge in the capacitor. What is C? Capacitance of this capacitor. Capacitance of the capacitor. Right? No flow of current through the inductor, so the magnetic energy in the inductor is 0. Magnetic energy in the inductor is 0. Right? What is the total energy of the system? The total energy of the system is equal to sum of electrical energy and magnetic energy. Sum of electrical energy and magnetic energy. Right? So total energy UT is equal to the energy stored in the inductor or capacitor is of Qm square divided by C, and the magnetic energy in the inductor is 0. Magnetic energy in the inductor is 0. So the total energy of the system is completely electrical energy. The total energy of the system is completely electrical energy. Electrical energy, right? That is wholly electrical. When? If there is no flow of current through the inductor. If there is no flow of current through the inductor, magnetic energy value is 0, but the electrical energy in the capacitor is a maximum, the maximum energy of Qm square divided by C. Now, the total energy of the system is equal to sum of electrical energy and magnetic energy. Electrical energy maximum, that is of Qm squared divided by C, but magnetic energy is 0. So the total energy of the system in this state is wholly electrical, right? And next, the capacitor begins to discharge. The capacitor, starts to discharge. If the capacitor starts to discharge, an electric current I is flows through the circuit, or the current I is flows through an inductor. That is, the capacitor sends or transfers a part of the energy to an inductor. That is, some part of the energy is stored in the capacitor and the remaining part of the energy is stored in the inductor. If the capacitor starts to discharge, an electric current flows through the inductor. So there is a energy stored in the capacitor and as well as inductor and as well as capacitor. Right? Now, when the capacitor starts to discharge, the amount of charge in the capacitor is decreases. Suppose at a given instant, the amount of charge in the capacitor is taken as Q. Right? So due to the decreasing of electric charge from the capacitor, the electrical energy in the capacitor is decreases. Now, the electrical energy in the capacitor is of Q square divided by C. Okay, at a given instant, the amount of charge in the capacitor is Q. So, the energy in the capacitor at that instant is U suffix E is equal to of Q square divided by C. And the remaining energy is transferred to the inductor. Okay, the energy in the inductor is called magnetic energy. The magnetic energy in the inductor at that instant is U suffix B is equal to of L I square. Right? Now the total energy of the system is sum of electrical energy and magnetic energy. Electrical energy of Q square divided by C, and the magnetic energy is of L I square. So this is total energy. So in this state, the total energy of this system or the total energy stored in the LC circuit is the same as that of the total energy of the LC circuit in the initial state. The total energy of the LC circuit in the initial state, that is UT is equal to UE, because in this state the electrical energy stored in the capacitor is maximum. Okay, that value is equal to sum of electrical energy and magnetic energy in this state. Right? So sum of electrical energy and magnetic energy gives total energy. That total energy is the same as that of the total energy of the LC circuit in the initial state. Right? And next, right, already I told the energy stored in the capacitor is in the form of electrical, whereas the energy stored in the inductor is in the form of a magnetic field. So when an electric current flows through the inductor, a magnetic field is established in the inductor. Okay, magnetic field is established in the inductor. So that is why an energy is stored in the inductor, which is called magnetic energy. It is given by of L I square, where L self-inductance of the inductor and I the amount of current flowing through the inductor at that instant. Right? Okay. And next, suppose the capacitor is completely discharged. That is, the charge in the capacitor is zero. If the charge in the capacitor is zero, what about the electrical energy in the capacitor? The electrical energy in the capacitor also zero, because the electrical energy depends on two factor, or the amount of electrical energy stored in the capacitor depends on two factor. One is amount of charge in it, and the second one is its capacitor. Right? In this state, the total energy or the charge in the capacitor is 0. So that is why electrical energy in the capacitor is 0. Electrical energy in the capacitor is 0. Right. Even though the charge in the capacitor is 0, there is a flow of current through the inductor. There is a flow of current in the inductor. Even the charge in the capacitor is 0, there is a feeble amount of current flowing through the inductor. So the energy, that is maximum value of current flowing through the inductor. The maximum value of current flowing through the inductor, even the capacitor is completely discharged. If the capacitor is completely discharged, there is a maximum amount of current. Suppose I suffix M. Maximum magnitude of current flowing through the inductor. So the magnetic energy stored in the inductor is maximum. That is U suffix B is equal to of L I M squared. This is maximum energy, right? Even though there is no charge in the capacitor, there is a maximum amount of current flowing through the inductor. This is because the inductor does not stop the current immediately. The inductor does not stop the current immediately. So that is why the current flowing through the inductor is a maximum. So maximum amount of magnetic energy stored in the inductor, it is given by U suffix B is equal to of L I M square. Of L I M square. Right. Now total energy is equal to sum of electrical energy and magnetic energy. Electrical energy is 0 and magnetic energy of L I M square. L self-inductance of the inductor and I M maximum current in the inductor. Maximum current in the inductor. So here total energy is equal to of L I M square. That is total energy is completely magnetic energy. That is wholly magnetic. Right. In this third state, in the second state, a part of the energy is in the capacitor and the remaining part of the energy is in inductor. So the total energy is equal to sum of the energy in the capacitor and the energy in the inductor. But in the third state, there is no charge in the capacitor. So charge value 0 means electrical energy value is 0. So the entire energy from the capacitor is transferred to the inductor. The entire energy is transferred to the inductor. So that is why the energy in the inductor is a maximum. It is given by of L I M square. Here maximum current flowing through the inductor. So that is why magnetic energy is maximum. But the electrical energy value is 0. So total energy is completely magnetic. Total energy is completely magnetic. So this energy is the same as that of the initial state. That energy is equal to that is the energy of Q M square divided by C, that is UE. Okay. In the third state, the total energy of the LC circuit is similar to that of the total energy of the LC circuit in the initial state. So, but the only difference is that the total energy is completely magnetic in the third state, but in the first state, the total energy is completely electrical. Right. And next, already I told. If the capacitor is, there is no charge in the capacitor, there is a flow of current in the inductor because the inductor does not stop the current immediately. Right. And at one particular stage, the magnetic field in the inductor, gets collapsed. There is a magnetic field around the inductor. That magnetic field is maximum. Magnetic field is maximum. So whenever the magnetic field around this inductor gets collapsed, then the current flows in the circuit in the same direction. Right. So the magnetic field around the inductor, whenever collapsed, it sends the current. Through the circuit, or it sends the current towards a capacitor. So due to this, the capacitor gets charged. If the magnetic field around the inductor gets collapsed. If the magnetic field collapses, the inductor sends the current through the capacitor. So due to this, the capacitor gets charged. The only difference is that the capacitor charged in opposite direction. The capacitor charged in opposite direction. That is, the first plate in initial state, the first plate having positive charge, second plate having negative charge. But in this state, the second plate acquires a positive charge, whereas the first plate becomes a negative charge. First plate becomes negative charge. So the only difference is that the capacitor charged in opposite direction. The capacitor charged in opposite direction. That means the inductor sends a part of the energy to the capacitor. Part of the energy to the capacitor. So there is a charge stored in the capacitor. Suppose amount of charge stored in the capacitor is Q. Then the electrical energy in the capacitor becomes UE is equal to of Q square divided by C. Of Q square divided by C. And the remaining part of the energy is in an inductor. So that is magnetic energy. And magnetic energy is of L I square. Of L I square. Right. Now total energy is equal to sum of electrical energy and magnetic energy. And electrical energy is of Q square divided by C, and magnetic energy of L I square. Of L I square. So whenever the magnetic field around the inductor gets collapsed, the inductor sends an electric current of I towards the capacitor. So due to the flowing of current I, the capacitor gets charged. At a particular instant, the amount of charge in the capacitor is suppose Q. So the energy in the capacitor becomes U suffix E is equal to of Q square divided by C. At the same instant, the amount of energy in the inductor is U suffix B, which is equal to of L I square. Of L I square. Now the total energy of the system is equal to sum of electrical energy and magnetic energy. That is equal to of Q square divided by C plus of L I square. Of L I square. So this total energy is the same as that of the total energy in the LC circuit in the previous cases. That is the third state, second state and first state. Okay. So in the fourth state, a part of the energy is in capacitor and the remaining part of the energy is in inductor. So total energy is equal to sum of energy in the capacitor and inductor. That energy is the same as that of the energy in the LC circuit in the previous cases or in the previous states. Right. And next, the current in the inductor gradually decreases and it becomes zero. At one particular stage, the current flowing through the inductor is gradually decreases and it becomes zero. If a current through the inductor is zero, means there is a maximum amount of charge is stored in the capacitor. The maximum amount of charge in the capacitor is denoted by Qm. Right? So that is the inductor sends the entire energy in it to the capacitor. So the amount of current in the inductor is zero. If current in the inductor is zero, means there is a maximum amount of charge stored in the capacitor. It is taken as a Qm. Right? Qm. Right? Therefore, the electrical energy in the capacitor is U suffix E is equal to of Qem square divided by C. Of Qem square divided by C. There is no current in the inductor, so magnetic energy value is zero. U suffix E is equal to of Qm square divided by C. That is maximum electrical energy in the capacitor in the in the fifth state. But there is no current in the inductor. That is why the magnetic energy in the inductor is zero. Magnetic energy value is zero. Right. In this state, the total energy is equal to UE plus UB. UE of Qm square divided by C, and UB value is zero. So total energy is equal to of Qm square divided by C. That is, the total energy is completely electrical. Wholly electrical. So in this state, the circuit is similar to that of initial state. Right? The only difference is that the capacitor charged in opposite direction, right? See the first state of the LC circuit and the fifth state. Here first plate having positively charge, here the first plate having negatively charge, and second plate having negatively charge, but here positively charge. But the state is almost same in the initial state and this fifth state. The only difference is that the capacitor charged in opposite direction. The capacitor is charged in opposite direction. But in this state, the total energy of the LC circuit is wholly electrical, because there is a maximum amount of charge in the capacitor but no current in the inductor. So current in the inductor is 0, so magnetic energy 0. The charge in the capacitor is a maximum, so there is a maximum electrical energy. So the total energy of the system is completely electrical, right? So here this is a completely charged capacitor. When the completely charged capacitor is connected to an inductor, then the capacitor starts to discharge. Right. So capacitor starts to discharge. When the capacitor starts to discharge, it sends electric current I through the inductor. If the capacitor gets discharged, the amount of charge in the capacitor is decreases. Now the charge in the capacitor is Q. So the energy in the capacitor becomes UE is equal to of Q square divided by C. U suffix E is equal to of Q square divided by C. So there is a flow of current through an inductor. So there is a energy stored in the inductor. It is called magnetic energy, and magnetic energy UB is equal to of L I square. Right? So this is a completely charged capacitor. When the completely charged capacitor is connected to an inductor, it gets discharged. When the capacitor gets discharged, the charge in the capacitor decreases. So there is a flow of current through the inductor. So due to the decreasing of a charge in the capacitor, the amount of energy in the capacitor decreases. At a given instant, the energy in the capacitor is U suffix E is equal to of Q square divided by C. Here, there is a flow of current I through the inductor. So definitely there will be a energy in the inductor. It is called magnetic energy, and magnetic energy is U suffix B, which is equal to of L I square. Right? Now the total energy is equal to sum of electrical energy and magnetic energy, that is equal to of Q square divided by C plus of L I square. So in this state, the total energy of the LC circuit is equal to the sum of electrical energy in the capacitor and magnetic energy in the inductor. Right? But in this diagram or in this state, the capacitor sends an electric current in anti-clockwise direction. But in the second state, the capacitor sends the current through the inductor in clockwise direction. Here current is flowing along clockwise direction. But in this sixth state, the capacitor sends an electric current in anti-clockwise direction. Right? Okay. So already I told the current is flowing through the inductor. There is a magnetic energy stored in it. That means the capacitor sends part of its energy to the inductor. So only a half part of the energy is in the capacitor, and the remaining half is in an inductor. Right? So at one particular stage, the charge in the capacitor is completely discharged. That is, it reduced to zero. That is, Q value is 0. If the capacitor is completely discharged, the current flowing through the inductor is maximum. The current flowing through the inductor is maximum. It is denoted by I suffix M. But the charge in the capacitor is 0 because it completely exhausts or completely discharged. So there is no charge in the capacitor. So electrical energy value is 0. There is a maximum amount of current flowing through the inductor. So magnetic energy is maximum. So magnetic energy of L I M square. of L I m square. Right. Now total energy is equal to sum of electrical energy and magnetic energy. Electrical energy is 0 and magnetic energy is of L I m square. Right. Now the total energy is completely magnetic. That is wholly magnetic. Completely magnetic. Right. So total energy of the LC circuit is completely magnetic in 6 states. So this is first state, and this is second, and third. This is fourth one. This is sixth state. This is the seventh state. So in the seventh state, the total energy of the LC circuit is completely magnetic. Completely magnetic. Right. So if the capacitor is completely discharged, it sends maximum current through the inductor. So the electrical energy in the capacitor is 0 and maximum energy in the inductor. Maximum energy in the inductor. Okay, even though there is no charge in the capacitor, there is a flow of current through the inductor. Right? Because the capacitor inductor does not stop the current immediately. When the inductor allows current to the capacitor, if the magnetic field around the inductor gets collapsed. So there is a magnetic field around the inductor. Whenever this magnetic field gets collapsed, then it sends the electric current towards the capacitor. Right. Suppose the magnetic field around the inductor gets collapsed. The magnetic field around the inductor gets collapsed. Okay, due to this, the inductor sends the current through the capacitor. So due to the flowing of current I, the capacitor gets charged. So there is a energy stored in the capacitor. It is called electrical energy. Suppose at that instant the amount of charge in the capacitor is Q. So the energy stored in the capacitor is of Q square divided by C. Okay, here the magnetic field gets collapsed. So amount of energy in the inductor is gradually decreases. Okay, the remaining energy alone stored in the capacitor. That energy is called magnetic energy. It is given by of L I square. So electrical energy of Q square divided by C, and magnetic energy UB is equal to of L I square in the 8th state or in the state. Now the total energy is equal to UE plus UB, that is of Q square divided by C plus of L I square. So in this state, the total energy of the LC circuit is the sum of electrical energy and magnetic energy. So this energy also same or similar to that of or a similar amount in the previous states. That is the 7th state, 6th state, 5, 4, 3, 2 and 1. So by calculating the total energy of the LC circuit in all the 7 states, that total energy value is always constant. So that energy is the same at the top, the total energy of the LC circuit in the 8th state. Right. Then finally, the inductor sends the maximum current to the capacitor. So the capacitor gets charged with the maximum charge. The maximum charge in the capacitor is Qm. So if the capacitor gets charged with the maximum charge, the amount of current flowing through the circuit is 0. The amount of current flowing through the circuit is 0. Right? There is no current flowing through the inductor. So the electrical energy, magnetic energy in the inductor is 0. The magnetic energy in the inductor is 0. There is a maximum amount of charge in the capacitor. So there is a maximum electrical energy in the capacitor. That is of Qm square divided by C. Qm square divided by C, right? So this is final state, that is the ninth state, right? Now the total energy of the system Ut is equal to UE plus UB, and UE is of Qm square divided by C plus UB value is 0, right? Now the total energy of the system is completely electrical. The total energy of the system is completely electrical. That is, the circuit comes to its initial state. The circuit comes to its initial state, right? So this is initial state. So see the initial state of the circuit and the final state. The final state of the LC circuit is the same as that of initial state, right? In all the 9 states, okay, calculating the total energy of the LC circuit, that value is always constant, right? So here, whenever energy is given to the LC circuit, there is a electromagnetic oscillation. That is, first the electric current is flows along clockwise direction, and then it flows along anti-clockwise direction, right? The same process is repeated. The same process is repeated. So that is why an electromagnetic oscillation exists in this circuit. So such oscillation is called LC oscillation. LC oscillation. During this LC oscillation, the total energy of the system is always conserved. The total energy of the system is always conserved. Right. My dear students, already I told, if energy is given to the LC circuit, an electromagnetic oscillation sets up in the circuit, which is called LC oscillation. LC oscillation. If the inductor and capacitor in the LC circuit is ideal capacitor and ideal inductor means the oscillation exists in the LC circuit indefinitely. Okay, that is, the oscillation is maintained infinite. Okay, that is, the oscillation never stop when if the inductor and capacitor in the LC circuit is ideal. Okay, that oscillation is called undamped oscillation. Undamped oscillation. The undamped oscillation is like this. That is, amplitude of the oscillation does not change. So this is amplitude. The maximum displacement of the wave is called amplitude. The amplitude of the oscillation does not change. Okay, in which circuit? In LC circuit. When? If the inductor and the capacitors are ideal. But no capacitor, no inductor is ideal. So in this situation, there is a energy loss in the inductor and as well as a capacitor, right? So due to the energy loss, the amplitude of the oscillation is gradually decreases and it becomes zero. So such oscillation is called damped oscillation. This is a damped oscillation. Right, this is undamped oscillation. Undamped oscillation. Right? If the inductor and the capacitor and the inductor are ideal, the oscillation exists in the LC circuit is indefinitely, so we can get undamped oscillation. But practically, no capacitor is ideal, no inductor is ideal. So there is a energy loss in every state or in each cycle. So due to this, the amplitude of the oscillation that produced in the LC circuit is gradually decreases and it becomes zero. So such oscillation is called damped oscillation. But this is undamped oscillations. Thank you, student. We will see in the next class.